About a month ago, I was teaching a Java class, and I was doing a demo of closures in Java. That is, some students wanted to know if Java had closures, and I had to tell them, well, Java doesn't have really proper closures, but they have something very similar, or we can work around that idea. And the students liked the example and asked me if I could put it online somewhere. And I thought I'll make a little demo and maybe put it up on YouTube. So that's what I'm doing. Anyway, we'll start by creating a little Java project, and let's see, little Java project, and call it com size spike demo. And I'll make a class so we have some place to do the demo. Let's put it in the package com size spike demo, and I'll call the class closure demo. Okay, and let's just have a little main function. Now, as story goes, Gauss supposedly, as a youngster, was asked by his teacher to summarize all the numbers between 1 and 100, and he did so very quickly. At that time they had a slate. They slammed it down on his desk, and the teacher wondered how he did it, and he had, of course, paired up the high and low number and summarized them. So I thought I'll make a little a Gauss demo here. I said Gauss should have said, and then plus a sum of numbers from 1 to 100, say. Now I don't have that method, so I'm going to have to write it, and I'm going to create one right below. Int sum, int min, int max, and then we'll summarize the numbers. So we say int sum equals 0, and then for int I equals 0, no, for min I less or equal to max, if we use inclusive, I plus plus, and then sum plus equals I, and then return the sum. Now if I done that correctly, the sum between 1 and 100 should be 5050. So let's see, I'll run this as a Java application, and the console output comes and says Gauss should have said 5050, which he obviously then did, and we managed to do it correctly also as Java programmers. Now let's say your boss liked your solution so much that they say, well, we have this other problem that we need to solve, and that is we need to summarize all let's say squares from 1 to 10. Sum of squares from 1 to 10, make them nicely aligned here. Say sum from 1 to 10, so this will be sum of squares. Okay, now what we would do as programmers typically in the Java world is we say, well, we kind of solved this before. We do a cut and paste, sum of squares, and from min to max, and the algorithm is different. We need to now do I times I. And if I've done that correctly, I think that should be 385. Let's see if that's correct. And yes, it is 385. Okay. Now, someone that has been taught, say, on the Lisp language will look at what you've done and they say, are you crazy or nuts or whatever their preferred adjective would be, and say, this method right here and this method right here are identical, except for this part right here. So why didn't you use a closure? And as Java programmers or object-oriented programmers in general will say, closure, what is that? And we're not used to breaking things into closures. And Java doesn't have direct support for it, and that's probably why we're not used to using that as a design artifact. But we can get pretty close in Java. So let's say, for instance, we have a sum function, and the idea here is that we do the sum from min to max using a function. and say function f. And then let's say we could do right here, we say, okay, I want f of I. Okay, now notice I got a lot of errors here. First error is that function cannot be resolved to type, and the method f of int is undefined. Okay, well, let's say we could pass on a function like this. Say this is basically f of I equals I. That would be nice, right? Well, in some languages you can actually do that, but Java is not one of them, so we can't do it exactly like this. But what we could do is we could say, okay, I'm going to make this function into a object, and we can start by making function an interface. So I'm going to click on the little icon, say create an interface function. And Eclipse is nice, it does a lot of the work for me. So now I have a interface function, and then we got rid of the first error. But this error says, you know, f of I doesn't work. Well, it wouldn't work in using this syntax at all, but what I could do is I could say f.apply. So apply this function over a value I. Still have an error here, but the error here now is something that Eclipse can fix. It says, do you want to create a method apply on the type function, which is what I want. So the interface now has that that function also. So okay, go back here now. I fixed it. There are no more errors here. But how do we then communicate to the sum function that we want to just, in the first case, just simply return I, and in the second case, take the square? But what we could do is we could create a new function on the fly using what's in Java called an anonymous in a class. So we could say new function. And as you probably know, you can't just create a function, but you can define the implementation of a function on the fly using this construct, as I said, called anonymous in a class. So we could say our function here should simply return I. Okay, and then in the second case, which we have the square, we can create a different function, and now we could reuse the same sum construct and say new function. Again, I'm going to do the same thing and let Eclipse add the method for me, or the unimplemented method apply. Okay, that looks good, but here we need to do I times I. That means this method here, sum of squares, is no longer required. And in theory, this should yield exactly the same result. Let's see if it does. I'll run the closure demo again, and it says exactly the same. Gauss, should I say, 5050. Sum of squares from 1 to 10 is 385. So we implemented exactly the same thing, but in a completely different way. And we've taken advantage of this construct called closures. Okay, now some people don't like this idea of anonymous inner classes, and we could refactor this a little bit. We could say, okay, this square function, I'm going to take this function and I'm going to use the refactoring tool in Eclipse. Now you can't actually see what I'm doing. You see probably that I select refactor, but there is a submenu here, and one of the options is convert anonymous class to nested, which is what I'm going to select. And then it's going to ask me what I want to call the function or the class, and I'm going to call that for the square function. Okay, and we can declare it as final. Okay, so that's good. Now notice that the code basically says new square function. It's been made into an anonymous, from an anonymous class, it's been converted into a nested class. Now we might want this function class to be in a separate file, which we can also do in Eclipse very easily. Right click and say refactor, and now you can probably see this, or you can see part of it, but there's one option says move type to new file, which is what I want to do. And now if we go and look at the package explorer, Explorer, you'll see that the square function is now a separate file. Okay, and of course we could do the same thing with the other anonymous inner class too. If you don't like anonymous inner classes, we could refactor that also. Again, do the refactor and convert anonymous class to nested. Maybe make this public. Let's call this just simply the echo function, since it just returns the value that we pass in. And again, we could take this class and refactor it and make that into a separate file. And there we go. Okay. Now, so what have we achieved here? Well, what we've achieved is we've managed to reuse this little algorithm. And the way we did that is by abstracting away the thing that is different from the two different places where I used the algorithm into an object. And this object plays the role of a closure. That is, it's an abstraction of an algorithm that we created. And of course, we could create it on the fly as we saw, or we can make it a separate class. The reason why you would make something anonymous in a class versus when you would make it into a separate file is something I'm going to leave out. It's a good discussion. In general, you would probably use an anonymous in a class if this was the only place you used it, this function. Of course, if you want the square function and the echo function to be reusable, you could do that. Now, in the class, I also showed you how the closure could be used further. That is, for instance, this whole idea of sequence here could be made into an object too. We could have replaced the min and max here with simply a number sequence. And then we could have said, for instance, if the while sequence has more, and then we could have said sequence dot apply to C++.next, right? So we did that in the class. I'm not going to do that right here. It's just another closure, a closure that understands. Well, a closure is another abstraction where the sequence or a number sequence have been wrapped, and I showed you how you could make say a primary number sequence or a Fibonacci's number sequence, or a simple sequence like the one we have with consecutive integers. But I'll leave that out for now. So what we've seen is a way of doing closures in Java. It's not as pretty as in languages that do support closures, but it's pretty close. We have to create an interface typically that abstracts what we want the closure to do. It's fairly generic. You see this in the Java libraries. You'll see it, for instance, when we create threads, for instance, and they have the closure is a simple run method that we implement. And in this case, we had a closure that calculates a number given an input. Similar idea. I hope you enjoyed this, and I'll see if I can expand on these examples later on and maybe put some more of the things we did in the class online. Thank you for listening.